Welcome back, everybody. Right now we're going to be going through the measurement lab, which is our first in Physics 1. And you might recall, I said that physics, a lot of physics, is about comparing values. Like, for example, y and x. All right, well, if we say y equals 3x, if we were to plot that on the graph, we would have a slope of 3 because that fits the model of y equals mx, and 3 fits in that m position right there. So that coefficient right there out in front of the x, that 3, represents the slope, or you might say the relationship of how x changes as y changes. All right, but we're going to do that not with just arbitrary x's and y's, but with parts of circles. And as you can see here on the left, whoop, I just started moving that around. I don't want to do that. I want to lock that in place. And I'll do that right now. Sorry about that. We have a series of circles right here. We've got 5 of them. And the first thing you're going to do as you're following along in your measurement lab circles document is in lab, you're going to take your graph paper, which you see in the background right here, and you're going to draw 5 or maybe 6 circles onto it. All right. Now these are going to be traced around objects that you have at your disposal. It could be a plate or a coffee can or something. And it's even okay if they overlap here a little bit. That's perfectly fine. And a lot of times students will try to knock themselves out trying to get 5 circles to fit on with overlapping. It's perfectly fine if they overlap. So you can have 5 circles drawn. And as you look in the procedure in part A and part B, we're comparing radius of the circles against 2 different things. We're comparing, in part A, the radius of each circle. So I'll call that radius 1, call this radius 2. Oh, that's kind of weird. Erase that there. We'll go with radius 3 here, radius 4, and radius 5. Okay? And as it says, you're going to set up data columns, and you're going to do this by hand at first. So set up a data column on your graph paper, entitled radius. That's a pretty horrible IU. It's supposed to be IUS right there, and you're going to measure that in centimeters. That's going to be one of our main units of measurement in physics. All right, and so you're going to measure radius 1. Write it down in centimeters. Radius 2. This is just not working for me today. Let me give it a better try here. Radius 2. Radius 3. There we go. Radius 4. And radius 5. And you're going to compare this now against circumference. Now you may know a relationship between the radius of a circle and its circumference. You may know a mathematical relationship, but I don't want you to do that quite just yet. Without a calculator, without calculating anything, I want you to physically measure the circumference of each circle. And probably the best way to do that would be with a piece of string. So whether it's a coffee can or something like that, or a roll of tape maybe, set that down and measure around it and straighten the string back out and measure what C1 is. Stretch it around your second object. That's a pretty horrible circle, but that's okay. And then straighten it back out and measure C2, C3, C4, that's even worse, C4. I'll just erase that right there. Let me give it another try. C4, which I'm told is an explosive, by the way, and it's not much better. C5. You'll measure all 5 of these circumferences and mark them down in your data table, as it says in the procedure. So CIRC, and that'll also be in centimeters as well. Circumference 1, circumference 2, circumference 3, circumference 4, and circumference 5. Make sure you make your data tables nice and neat, because I can't use a straight edge right here. I'm not making very straight lines, but you're going to want to do that with a ruler. Make nice straight lines, divide them up, make your data look pretty. Okay? So we have 2 things we're comparing against each other. I said at the very beginning it's kind of like comparing an x and a y, and that's exactly what we're going to do with this data. We're going to put 1 on the x-axis. Cancel. We're going to put 1 on the x-axis and one on the y-axis. The x-axis is going to be your radius. And that's going to be in centimeters. When you draw this out, and you will do this by hand at first, you're going to want to write in the unit right there, in addition to the title, so radius in centimeters, and also your circumference. I'm going to abbreviate for now circumference, and that also is going to be in centimeters. So both of these are lengths, and so we're dealing with like units right here. All right, so you're going to go radius 1, circumference 1, and put a point. Radius 2, circumference 2, put a point, so on and so forth. Now I'm drawing these in a straight line right here. They may or may not be in a straight line, but I think you have an idea of what that may turn out to be. All right. When you get done, well, I'm just going to have to tell you, it will be a straight line. We expect it to be a straight line. You're going to want to draw the best fit line through those points. All right. So you have your x values, you have your y values, and what relates the x and the y? Well, our slope, our m right here. So remember, you're still doing this all by hand. How can you find the slope of this line that you've plotted? How can you find the relationship between radius and circumference? How can you find this m right here? Well, you can pick a different color right here. Let's go with, I don't know, yellow's pretty bad. Let's go with brown. All right. You can take R2, or pick any 2 points. R2, yeah, back up here for a second. Sorry about that. Let's pick 2 points here on this line right here. We want to find this slope right here. And we know that slope is rise over run. Okay? I was saying R2 a minute ago right there. We'll just say the y, come on now, over the x. So you could say your y2 minus y1, this distance right here, and your x2 minus x1 right there. That is your slope. So we want to find what this slope m is right here, and initially you're going to do that all by hand. All right? Calculate the slope of the best fit line that you're going to do by hand.